The relational operators are all about the relations and all about the Boolean true and false. Remember, there is a Boolean data type which is only true or false. Now let's try to see how is it. To initialize a variable to a true, you write status equal true with T capital. Remember, the T is capital. If you try to print status, it will print true. There is also the not operator. When you say not status, if a status is true, not true will be false. If the status is false, not false will be true. The other thing is a bool function. The bool function, if applied on 0 or 1 as a string, it will give true. But if applied on an empty string, it will give false. Applying it on integers or floats will give true. Unless you are applying it on 0, it will give false. So overall, the bool function will return false only for two cases, either an empty string or a 0 value. 0 value, not a string with a 0 value. Now let's see what do we mean with relations. I can say in normal English, is 3 greater than 5? The answer is false. In programming, we use this operator to indicate greater than. In a similar way, is 3 less than 5? True. We use this operator to indicate the less than. Equal, we use the equal to indicate the equal. So differentiate here between the equal that we use it for the assignment and the equal without spaces between them to express the equality. Is 3 value equal to 5? The answer is false. We can also express greater than or equal with greater than equal this way, or we can make more comparisons. The other one here is the not equal. So 3 not equal 4 true, 3 not equal 3 false. So these are the available operators to compare two numbers even in math. So let's code them. You code them in the very exact way like I was doing here. 3 greater than 5, 3 not equal 3, and so on. You can also make something like 2.5 plus 3 less than 4. 3 less than 4 is true. So the value of true can be evaluated here to 1. 2.5 plus 1 is going to be 3.5. 5 times 3 less than 4. 3 less than 4 will be evaluated to true, which is internally like 1. So multiplying with 5 is 5. But here is 0. So the moral of that is also true is internally like a 1. And false is internally like a 0. So that's why this expression are adding 1 here or multiplying with 1. In a very similar way, we can put the value of the expressions in variables. So we have here x and y with 3 and 5. We can say x greater than y or x not equal y. So far so good. I can also create a variable result and put the result of the expression in it. So x equal y, we put it in result. Then we print, it will be false. So we can use variables to express the relationships. Another interesting thing is comparing strings. Comparing strings is the same idea as an English dictionary. You compare letter by letter, and the one has a smaller letter comes first. For example, let's in dictionary compare love with zebra. You will notice that the L comes in the dictionary before the Z. So the word love would be smaller than the word zebra. What about love and long? You will notice they have common letters L and O, so this cannot make a judgment. But now we have the V and the N. The V and the N, the V is greater than N in the dictionary. So this make it a wrong expression. Love not equal long, definitely true. Now, what if two words, one of them is smaller than the second in terms of number of letters, and they share all of the letters here? So C is C, O, counter, the whole word counter. The one that is smaller in length in this case is coming first in the dictionary. What if this C, what if the C was Z here, then the counter attack will be smaller. So we only use the length if one of the two expressions are exactly in the same letters one by one when compared to the other guy, and it ended. So the smaller one comes the first in dictionary. So far so good. In the dictionary, we don't care about lowercase and uppercase, but here we have some rules. Upper letters are smaller than small letters. For example, the letter A is smaller than the letter A small, and A capital is smaller than Z small, and the Z capital is smaller than the A small. So any capital letter is smaller than the small letter. If I have the word love and love, but V is capital, then this one comes first. Love and long is now again coming first because the V is smaller than the N. A few relevant things. The input string is always smaller than other guys. The space is smaller than letters. Digits are smaller than letters. Might be useful sometimes to know. The last critical thing to know about is the comparing floating point. You should know that Python has internally an approximation representation for floating point. So when it comes to compare expressions, you will typically fail. Let's see this example. We put the value of A with 3 over 7. The value of B with 0.1 plus 3 over 7 minus 0.1. If you try to print the A and B, they have a lot of shared characters, shared digits. But you see here in the end, they aren't very equal actually, because they are approximations. If you try to make a comparison like that, the result will be false. Another similar example. So here you expect it to be true, but it's false. Another example. X was 5, but Y is 4,4,9,9,9,9,9. So if you compare them, you expect them to not be equal. But Python is going to evaluate Y to be also 5. So this expression is going probably to give true or even false. We aren't sure. The moral of that is, if you have some expressions like that, they are typically will not be equal. So avoid comparing them directly, unless something very, very explicit, like something like very naive. If 5 equal 5, that will work. But any complicated expression, big chance it will not work. Later we should learn how to handle that in a proper way. Finally, the precedence. The relational operators comes in less precedence order than the one that we learned. For example, if I have an expression like 1 plus 2 equal 3, which one will be evaluated first? Is it 2 equal 3? Then we add 1 plus it, which will be 0 now. Or we are going to add the plus first. From the table here, we know that the plus has higher priority. So 1 plus 2 will be evaluated first. Now it will be 3. 3 equal 3 will be true. In a similar way, 16 equal 2 to the power 4. The power has a higher order. So 2 to the power 4 first is compared with the 16. That's all.